what we have been doing beta, sorry. I told you oscillations are of two types. One is periodic and non-periodic. Periodic is again two types. One is oscillatory, another one is non-oscillatory. Oscillatory is again bifurcated into SHM and non-SHM part of relation. In this one, we are talking about a simple harmonic oscillatory motion, that is an SHM, where generally net force acting is directly proportional to displacement in opposite direction. Beta. Minus sign indicates the displacement in opposite direction to the power of n. Here the motion will be in oscillatory but not in simple harmonic motion. If n is equals to 1, it will be an SHM, so F net will be directly proportional to your displacement, that is nothing but of your minus of your y part of relation. Is it clear, beta? Sure. If I'm writing Newton's second law beta from this one, see here. F net is equals to, generally if I'm writing, F net will be equal to your mass into acceleration. And this will be directly proportional to, if I remove the proportionality constant, we'll get some constant, that is minus of your k into your y. Minus of your k into your y part. That means m into your a is equals to, so I can write here m into your acceleration can be written as of your d square y divided by your dt square is equals to minus of your k into your y. So therefore I can ultimately write d square y divided by your dt square is equals to your minus of your k by your m into your y. Isn't it? If I take this one inside, this can also be written as of your d square y divided by your dt square plus of your k by your m into your y is equals to 0. So this is your differential equation of your simple harmonic motion. Okay, so I can say this one is your standard equation of SHM on which the problems are generally framed. Okay, if the particle is oscillating in vertical direction, better. Like if this is a particle is going from mean to extreme, again extreme to mean, again from extreme to your mean, again mean to your extreme. Okay, this one is your mean position, this one is your extreme position, and this one is also your extreme position. Clear right now? Okay, so at that time, in the place of your d square x, will be writing d square y by your dt square plus of your k by your m into your x will be equal to your 0. Okay, if the particle is oscillating from mean to extreme like this, extreme to your mean, then mean to your extreme, and extreme to your mean. So this is your mean position, this is your extreme position, this one is also your extreme position. So here I can write this one as d square into your x divided by your dt square plus of your k by m into your x is equals to 0. Okay, and one more term which is very important you need to remember, that is about your angular frequency. Okay, so angular frequency represented by letter omega. Omega is equals to how much better? 2 pi by your capital T. Reciprocal of a time period is known as frequency. It is represented by 2 pi into your f. Okay, and omega is also written as by the formula. One more important relation here. Omega is also written as of your under root of your k by your m. Very important relation. But that means I can write here k by your m will be equal to how much? Omega square. So therefore, standard equation can also be written as of your d square into your x divided by your dt square plus of your k by m can be written as omega square into your x is equals to 0. So this is the one more form of your standard SHM. Clear, beta? So what is the time taken here, beta? Time taken to go from mean to your extreme will be equal to how much, beta? One complete oscillation time period is t. Okay, so if I'm going from your mean to extreme, beta, like say from here, from mean to extreme, the time period will be your t by 4. Then again extreme to mean, it is t by 4. Again this one is your t by 4. Again this one is your t by 4. Total time period will be equal to capital T. Total time period will be equal to your capital T part of relation. And angular frequency is omega is equals to 2 pi by capital T, or that is equals to 2 pi into your m. D square x by your dt square plus omega square into your x is equals to your 0. Clear, beta? Is it clear? Sure. So on solving this equation better, on solving this, we get an equation y is equals to a into your sine omega t plus of your phi. This is your actual equation. Y is equals to a into sine omega into your t. A is your amplitude, omega is your angular frequency, t is your time, and phi is nothing but of your phase. Phi is nothing but of your phase. A is your amplitude. And omega is your angular frequency. Omega is your angular frequency part. Okay. So if I'm writing in terms of your x, in the x direction, if I'm writing, x will be equal to your a into your sine into your omega t, a into your sine omega into t plus of your phi. So this is the value of your x. X is equals to your a into your sine omega into t plus of your phi. Clear? X is known as what? Displacement of oscillator. Displacement of oscillator. Displacement of an oscillator. Clear, better? Okay. So these are some of the standard formulas which you need to remember in this one. So angular frequencies, omega is equals to 2 pi by capital T. In the standard equation in SHM, if I'm writing along x-axis, it is d square x by dt square. Solving this, we are getting the basic equation y is equals to a into sine omega t plus phi, where a is amplitude. If I'm writing in the x coordinate, x is equals to a into sine omega t plus phi. X is nothing but displacement of your oscillator. Clear? Sure. Next one. Seventh one. We got a displacement, we got the force. So what is the force we got? F is equals to some constant minus of k into x. Okay. K into your x part deflation. This k is nothing but what, beta? If I'm multiplying by mass on both the sides, isn't it? So if I write here F is equals to your m into your a, m into your a is equals to minus of your k into your x. Okay. So this k is some constant, beta. So acceleration will be equal to your minus of your k by m. See, I have written here k by m is equal to how much for me? See, k by your m. K by m is nothing but of your omega. K by m is nothing but of your omega part of relation. See, k by m is nothing but omega square. So here also I can write here acceleration a is equals to your minus of your this part of relation. So acceleration is equals to your minus of k by your m into your x part of relation. Clear, beta? K is nothing but some constant there. Can take care right now like this. F is equals to your m into your a, where k is nothing but equal to your constant. And the value of your k will be equal to your m into your omega square. Try to remember this one. So therefore I can write F is equals to your minus of your m into your omega square into your x. There means your mass of the particle. So I can write here F force acting on this particle will be equal to minus of your m into your omega square into your x square. So if I'm writing the acceleration for this particle, acceleration is equals to your force divided by your mass. That is equals to your minus m into your omega square into your x divided by m. Mass and mass will get cancelled. So acceleration of this particle will be equal to minus of omega square into x. So this is your acceleration. A is equals to your minus of your omega square into your x. If I take the magnitude, maximum will become for me omega square into your x part of relation. Clear, beta? See, generally if I'm taking this one as an oscillator, this is your mean position. So in mean position, x is equals to 0. If I'm going to the extreme position right now here, so x will be equal to your plus here. If I'm going on the left side, so x is also equal to extreme position, but it is minus here. Clear? So when the particle is going in this direction, displacement of the particle is in this direction. Acceleration of this particle is in this direction. When the particle is going in negative x-axis, the acceleration of the particle is towards your positive direction, like this. Clear, beta? Now, in the same way, if I'm talking about the velocity of the particle, in differentiation form also you can write, or else I'm directly writing the relation v is equals to your plus or minus of omega under root of your a square minus of your x square. You try to remember this one with a direct formula. V is equals to your omega plus or minus under root of your a square in minus x square. V will be maximum when x is equals to 0. That means at mean position. That is equals to your omega into your a. V max is equals to your omega into your a. At x is equals to how much for me? 0 at the mean position. Okay, at mean position. At mean position, V max will be equal to your a into your omega. Clear? General formula V is equal to plus or minus omega under root of your a square minus of your omega square part of relation. Clear? V will be maximum at your mean position. At extreme position, at the mean position, at mean position, a mean will be equal to 0. Okay. Velocity at your extreme position will be equal to 0. Acceleration at extreme position will be equal to minus of omega square into your a. Clear, beta? Is it clear? Let me give you one small example. Let's see this question. See this question, beta. Like say I got a particle right now here, which is executing in SHM. A particle executes SHM with an amplitude of 3 centimeters. When the particle is at 2 centimeters from the mean position, 2 centimeter from mean position, the magnitude of its velocity, is equal to that of its acceleration. Then its time period in seconds will be. Then its time period in seconds. Can anyone try it better? I'll give the options. First option is root 5 by pi. Second option is root 5 divided by your 2 pi. Third option is 4 pi divided by your root 5. And fourth option is 2 pi divided by your root 3. Come on, try it. Particle is executing SHM with an amplitude. That means amplitude is given for me 3 centimeters. Okay. When the particle is at 2 centimeters, that means x is equals to 2 centimeter from mean position. The magnitude of its velocity is equal to the magnitude of its acceleration. Then time period will be equal to your how much? Okay, so velocity will be equal to your omega under root of your a square minus of your x square is equals to amplitude will be equal to minus of your magnitude under property omega square into your x. This omega and this square will get cancelled, beta. So that is your under root of your, I can calculate it. Then time period is asking, okay, a square is given for me 3 square, that is nothing but 9, minus x is equals to your 2 square, that is nothing but 4, is equals to your omega value is 2 pi by capital T into x is nothing but equal to 2. Okay, so this will be equal to how much, beta? 9 minus 4, that will be equal to your root 5 into your time period T is equals to your 2 pi, 2 into 2, 4 pi. So T will be equal to root 5 divided by your 4 pi. 2 pi divided by T is equals to your root 5 divided by T is equals to 4 pi. Now, sorry, 4 pi divided by root 5. Time period is asking. So T is equals to your this value if I'm writing here, root 5 is equals to this t here, that is your 4 into your pi. So t will be equal to your 4 pi, this t will come down, so this will be your root 5. So t is equals to 4 pi divided by root 5. The third option will be the answer. Clear, beta? Picture. Option 2. How option 2? It's root 4 pi divided by root. Time period is asked, not frequency. Okay, so next one more question. Come on, try to do this question on velocity. Beta. A simple pendulum performs SHM at x is equals to 0 with amplitude capital A and time period capital T. The speed of the pendulum, the speed of your pendulum at x is equals to your a by 2 will be. Can anyone bet? I'll give the options for this one. First option is pi a root 3 divided by t. Second option is pi a divided by capital T. Third one is root 3 divided by 2 pi a divided by t. And fourth option is 3 pi square a divided by your t. So, the simple pendulum performs an SHM at x is equals to your 0 beta. Okay, at x is equals to your 0 with an amplitude A and a time period T. X is equals to 0 means mean position. The speed of the pendulum at x is equals to your a by 2 is asking. Anyone? Direct formula again. X is equals to your half of your amplitude is asking. Direct formula you can use. Option 1. Very good. Let me check. V is equals to plus or minus omega under root of your a square minus of your x square. Isn't it? So that is equals to plus or minus omega value is how much for me? 2 pi by your capital T into under root of your a square minus x is equal to how much for me? A by 2 whole square. That means a square divided by 4. Isn't it? So a square divided by 4 parts. So velocity will be equal to how much is asking right now. So this will become how much for beta? 2 pi divided by capital T into this will be under root of 3 a square divided by 4. So that will become for me 2 pi divided by your, this will become for me 2 into your t into root 3 into your a. This 2 will get cancelled. So answer will be root 3 pi into your a divided by your t. Root 3 pi into your a divided by t. So third option, first option will be the answer for this. Clear, beta? Sure. See, let us try to simplify this one, beta. X is equals to your a into sine omega t plus of your phi. Phi is nothing but what? Phase angle. See here. At t is equals to 0 if I am writing beta. First one. At t is equals to 0. That means mean position. X is equals to 0. That means particle is at your mean position. Particle is at mean position. When particle is at mean position, now use the above equation. X is equals to 0. That is equals to a into sine omega into t will be 0 plus of your phi. That means this will be equal to your a into your sine phi. That means a will also go cancel. So it is your a into your sine phi. Isn't it? So sine 0 means this will be equal to your sine 0. That will be equal to your how much value? Sine 5. That means phi value will be equal to 0 or phi value will be equal to 180 degrees. So I can write here x is equals to your a into your sine at phi is equals to 0 or phi is equals to your pi at t is equals to 0. So phi value I can take 0. So it will become for me y is equals to a into sine omega into t. So at the mean position x will be equal to your a into your sine of your omega into t. Clear, beta? Sure. So at t is equals to 0, x was also 0. That means the particle is at your mean position. If I take the opposite case of this one, like say other case, second one, at t is equals to 0, if particle is at extreme position, that means x is equals to your a. So now if I'm using the above equation, x is equals to a, that is your a into your sine omega t plus of your phi beta. This a and this a will get cancelled. So particle is at your extreme position. So this will be equal to your 1 is equals to your sine of your, this one is your omega t is 0 plus of your phi. That means 1 is equals to your sine of your phi. So sine 90 is your 1. That means this will be equal to your sine phi. This one will get cancelled. So phi will be equal to 90 degrees. That means if I write x is equals to your a into your sine omega t plus 90. Sine 90 plus theta is nothing but cos theta. So this will become for me x is equals to your a into your cos of your omega t. See, both of them are valid. It depends upon where the particle is being present. At t is equals to 0, if it is at a mean position, we'll be using the formula x is equals to a into sine omega t. And at t is equals to 0, if the particle is at extreme position, then we'll be using the formula x is equals to your a into your cos of your omega t. Clear, beta? Clear, beta? Sure. Let me try to do one application on this one. Be a little bit careful, beta. See this question. Like say, this is a particle which is oscillating in SHM. This is your mean position. X is equals to 0. This is your x is equals to your plus here. And this is your x is equals to minus here. Okay. Now what I'm doing is, if I'm taking somewhere here right now, the particle, at x is equals to your a by 2. X is equals to your a by 2. If the particle is moving towards the mean position, this is the direction of arrow mark. Okay. That means velocity is directed towards the mean position part. Now my question is, find the initial phase angle. Find initial phase angle. That means at t is equal to 0, the particle is at your a by 2. If direction is specified, then seeing the direction, we should give the answer for that one better. Okay. That means at t is equals to 0, x is equals to your a by 2. Now use the formula. X is equals to your a into your sine omega into t plus of your phi. X value is your a by 2, that is equals to your a into sine, this one is omega into t plus phi. So t value is how much here? 0. So it is your omega into 0 plus of your phi. So this will become for me, this a and this a will get cancelled. So this will become for me half is equals to sine of your phi. For what value of sine it is half beta? Sine 30 degrees is equals to your sine phi, I can write. So sine gets cancelled, phi is equals to 30 degrees. Or I also know that sine 150 degrees, sine 150 degrees is equals to your sine phi, because half is also equal to sine 150. This one also get cancelled. So phi is also equal to 150 degrees. So which I can take better right now? Which I can take, can anyone tell me? Shall I take 150 degrees or 150 degrees or 30 degrees? How do you identify that one? How do you identify that one? See, if I take this position somewhere here, this is the mean position. Okay. So this is the mean position. This is the particle which has been oscillating on this. The given problem for me is somewhere here. X is equal to how much for me? A by 2, directed in this direction towards the mean position. That means the particle may be either in the first quadrant or maybe somewhere in the fourth quadrant. Okay. That means when the particle is somewhere here right now, from mean to extreme, again from extreme, it is going to your mean position. Okay. That means if I'm taking this position right now here, either the particle may be in the first quadrant or in the second quadrant. So if I'm taking right now, this angle is equal to how much for me? One angle phi 1. And this angle is right now for me another one. That will be equal to your phi 2. Okay. When it is a particle position 1 and when it is at a position 2. When it is at a particle 1 beta, the particle is going towards your right. Particle 2, it is going towards your left. That means we should consider this angle, 150 degrees. Got it? Okay, beta. See, it is going towards the left. When the particle is in this coordinate, it is moving towards your right. Isn't it? This is from the mean position, na beta? Clear? Got an idea?
Yes, sir.
Sure. So we'll try to do some numericals based on this one in the tomorrow session of your class. Okay? Sure. Take care, beta. Bye.